Hi, boys and girls. It's Miss Purcell. We are on page 338 in our textbook. Today, we're going to be multiplying whole numbers by fractions. And if that sounds familiar, that's because yesterday we multiplied fractions times whole numbers. So let's revisit yesterday's assignment real quick. So if we are looking at a problem, and yesterday's assignment, we started, let me get a pencil that works, excuse me. We started with the whole number. So maybe you had a problem like 5 times 2/3. Okay? And we looked at two ways in our book, two different strategies to multiply it. The first one was to recognize that this problem could be repeated addition. We could solve it using repeated addition, where we have five groups of 2/3. So we would add 2/3 five times. Okay? So when we add these like fractions, and what makes them like are the denominators, we have thirds. When we add the numerators, we could say that we have five groups of two, so we have 5 times 2. So what we have are 10/3. And then we talked about an improper fraction. So if I had 5 pizzas and I gave you 2/3 of my pizzas to take home to share with your family, if I told you you were getting 10/3 pizzas, that doesn't make any sense to you because we don't usually talk in improper fraction form. So what we do is we treat the divisor or the denominator as a divisor. So we go over and we divide the numerator by the divisor, and we know 3 goes into 10 three times. We can make three groups of 3. That would use up 9. We would have 1 left over. So we would have 1/3. And we talked about the numerator came from the remainder, and the denominator is the divisor, which is the denominator that we started with. Now, if I told you that you were going to get 3 1/3 of my pizzas, then that would make sense to you. You would know you're getting a little bit more than 3 pizzas, not quite 4 of my pizzas, right? You're getting 3 whole pizzas and 1/3 of a fourth pizza. All right, so that's using the repeated addition. Now, a second way that we used it yesterday was what we called using the associative property. We multiplied and then we used the associative property. So when we multiplied 5 times 2/3, what we recognized is that this 2/3 can be the unit fraction 1/3 that we added to itself, 1/3 plus 1/3, or 2 times 1/3. If we kind of deconstruct it a little bit and make it 2 times 1/3, then this is going to give us a whole number 2 that we can multiply with this factor of 5. So we started out with the factor of 5, and then we broke this 2/3 into its unit fraction. Unit fractions are where we have 1 in the numerator part, so we have 1/3, but we had 2 of them. So 2 times 1/3 gave us this 2/3. Why we want to do this is because we can then take what we know about the associative property, and we can move the groupings here and multiply the whole numbers, and we get 10 times 1/3, and that's just simply 10 times, or 1/3 added to itself 10 times, which would be 10/3. Okay, and again, we've already converted it up here to a mixed number, so 3 1/3. Okay, same solution, obviously, because it's the same problem. Now, the third way I showed you was a little shorter, and I showed you that if you had a whole number times a fraction, what you could do is rewrite any whole number as its fractional form. And a fractional form of any whole number is when you take the whole number and make it the numerator, and you make the 1 the denominator. I mean, look at that. It is an improper fraction. So if we divided 1 into 5, it's going to go 5 times. So 1/5 is 5, or 5 over 1 is 5. So 5 over 1 times 2/3. And then we talked about the beauty of fraction multiplication, and really the reason we start with it is in fifth grade is because it's simple. You don't have to have the same denominators. So 1 times 3 is 3. That gives us our denominator. 5 times 2 is 10. and we get this 10 thirds, which we've gotten every time as our improper fraction, and we've already converted it by dividing, and that is 1/3, and I already see a mistake. You know how it is, the end of the day, I'm talking and writing, so this was supposed to be 1/3 up there. All right, so boys and girls, you see three different ways that we multiplied a whole number by a fraction. So today we're going to switch it up, and I really wish it would have said, how are we going to multiply a fraction times a whole number using models, because you're going to see a whole lot of models today. So I'm going to embed the visual learning video. It goes with what we're doing on the top of page 338. So please just follow along. If you can see, 1 minute, 28 seconds.
How can you multiply a whole number by a fraction? Think about this question during the lesson. Claudia has 8 yards of fabric. She needs 3/4 of the fabric to make a banner. How many yards of fabric does she need? Let's find out. You can use models to represent the problem. Why are there 8 squares in the model?
All right, I believe if you will go back and look at the question in green at the top of page 338, we have 8 squares because she has 8 yards of fabric, and each square here is representing one of those yards.
This model represents the 8 yards of fabric. You need to find 3/4 of 8. Step 1. You are finding 3/4 of 8. How many equal parts should the model be divided into?
Select your answer.
All right, so we're going to look at the denominator, and we need 4 equal parts. So
Since 3/4 of the fabric is needed to make the banner, use the denominator 4 and divide the model into 4 equal parts. 1/4 of 8 equals 1/4 times 8 equals 2. Step 2. Since you are finding 3/4 of 8, take 3 of those parts to make 6. What number determines how many of the equal parts you need to solve the problem? Claudia needs 6 yards of fabric to make a banner.
all right, so we're at 3/4 right here. I've drug it across. That takes us to 6 yards.
Now you know how you can model multiplying a fraction by a whole number.
All right, so that video went very quickly, so you know I'm going to slow it down a little bit. So we're going to look at models, but why don't we check our work with that little shortcut I showed you of multiplying a fraction by taking your whole number and making it a fraction. Wouldn't that be a great way to check your models? So here's another example. So we have 3/4 times 2. So if we're looking for 3/4 of 2, and you'll hear me a lot of times say the fraction part of the whole number, because that's what we're really looking for. We're looking for 3/4 of 2. So we're going to divide 2 into 4 equal parts. I know that because the denominator tells me how many equal parts there are. So here is, on a number line, 2. So we go from 0 to 1, so that's 1 whole, to 2. And if we break it into 4 equal parts, then we're going to have to break each number into half so that we have 4 equal parts. Okay, so each part is going to be half. So now we're going to look at 3 of those parts, 3 of these 4 equal parts. So if we look at these 3 right here, that's 3 of the 4 equal parts. So when I look at that, I see that we have 1 whole and 1/2 that we're looking at. The 1 whole and 1/2. So what we have are 3 halves, okay? So I'm going to back it up. Each part is 1/2, so 3 parts make 3 halves. And again, that doesn't make any sense. So if you go out to the side and you divide the numerator by the denominator functions as a divisor. 2 goes into 3 one time. When you subtract, you get that remainder of 1. That becomes the numerator, and we're working with halves. Remember, the divisor came as being originally the denominator, so it's going to go back to the denominator. So 3 halves is 1 1/2. And again, if I talk to you about having 1 1/2 of something versus having 3 halves of something, 1 1/2 makes better sense to you, right? All right. And again, I was just saying we could check that with standard multiplication where you would put 3/4 times 2 over 1 and then multiply it out and see if you get the same answer. All right, we can do some of those if you want to. So let's look at number 1. All right, explain why the product of 4 times 2/3 is the same as the product of 2/3 times 4. And guys, what I notice is I have the same two factors. The order has changed. So think about what this is called. If you think of what it's called, you can jot it down. Pause me a minute and jot it down. But it's called the commutative property of multiplication. And what that says is that the order of the factors does not change the product. So it doesn't matter what order we put the two factors in. It does not change the product. So that means the answer of this multiplication expression is going to be the same for each of these. So that was called the commutative property of multiplication. All right, number 2. In the problem at the top of page 338, that's the problem we were working with the fabric, what multiplication equation could be used to find how many yards of fabric Claudia did not use? All right, how many did she not use? All right, so you know what? She used 3/4. Okay, so let's go back and think about some of your 4th grade concepts. So if she used 1/4, if she used 3/4, I'm just going to jot this note down right here, then the whole thing would have been 4/4, right? So if the whole representation of her fabric was 4/4 and she used 3/4, that would be a subtraction. We have 1/4 left. Remember when we add and subtract like fractions. So I'm thinking if we wanted to find 1/4 of 8 yards, because that's what she started with, we would set up this expression right here. This equation is what we're going to work on. And so I am going to make this 1/4 times 8 over 1. All I'm doing is making this whole number a fraction. I get 8/4. I recognize that that is an improper fraction. It is top heavy. And I know that when I have an improper fraction, I divide the numerator by the denominator. And I can do this one in my head because I know that 4 divides into 8 2 times because 4 times 2 is 8. So I can just use that fact family. And my answer is 2. Excuse me. My answer is 2. All right. So if you need to pause the video and fill out your book, please do. I expect you when you come to school, whether you're out one day or whether you're out until the new year, because I know some of you have been quarantined because you've been exposed to someone who tested positive for COVID. No matter what your situation is, you should have the examples in your book. All right, we're looking at number 3, and we are going to model each product. They drew the circles for us. So we're looking for 2/3 times 6, and you'll hear me read this as we're looking for 2/3 of 6. So what I noticed is that I have 6 balls in my group, and I'm going to make equal groups of 3. So I kind of do some quick division in my head. I know that 6 divided by 3 is 2, so I'm going to have 3 groups of 2 to give me 6, right? So that's why these are kind of grouped in little balls with 2 in each group. So I am looking at 2 of the 3 groups here. So I would be looking at these 2 right here. All right. And what I noticed is that 2/3 of 6 equals 4. I visually see it. Right here are the 4 that make up 2/3 of the 6 balls. Now we can check it real simply. Remember I said we could use what I taught you yesterday where we're going to be multiplying times a whole number, but we're writing the whole number in its fractional form. So 2 times 6 is 12. Numerator times numerator. Denominator times denominator. So we get the answer 12/3 boys and girls, that doesn't mean a whole lot to me. I don't know what 12 thirds is because that's an improper fraction, and we don't speak with improper fractions. We speak with either whole numbers or mixed numbers, okay? So we divide the numerator by the denominator. This is just a basic fact. So 12 divided by 3 is 4. And right there explains and confirms that the answer is 4. 2/3 times 6 is 4. All right, if you need to pause the video and think about that a minute, rewind it and listen to me again, that's fine. Now let's look at 3/8 times 4. We have 4 of something broken into 8 equal parts. So that explains these 1, 2, 3, 4, 5, 6, 7, 8. And I know that if I take this 8 and divide it by 4, each of these have to be broken into halves. This one's a little harder model, I think, to draw. And we're looking at 3 of the 8s. So these are my 8 equal parts. So 1, 2, 3 of them would be this part right here. 1, 2, 3 of my 8s, right? Now, that gives me the answer 1.5. I can visually see 1.5. One whole circle here and half of another. Let's check it with that algorithm where we make the whole number a fraction by putting it over 1. 3 times 4 is 12. 8 times 1 is 8. All right, this one's going to be a little more challenging. I'm going to work it out to the side. 8 will divide into 12 one time. I have 4 left over. The 4 becomes the numerator, and the divisor was the denominator, and it's the denominator again. So I get 1 and 4/8. Now, that is not 1.5, but it really is. Look at this. We're going to talk about simplifying fractions a little more detail when we come back from Christmas break, but 4 is half of 8. So if you have 4/8 of anything, you have half of it. So this is really 1.5 simplified. And guys, that confirms the model that we're seeing here. I'm going to tell you, if I get stuck on a model, even I, your math teacher, will work out the expression or the equation. I'll find the answer, and then it oftentimes will help me with a model that I might be stuck on. So if that helps you, use that little bit of advice. All right, let's look at number 5. We need to find a product, and we're going to draw the models. So we're looking for 2/3 of 15. So I am taking 15 of something. I'm going to have 15, but I'm going to make it groups of 3. Okay? Now, if you think about that, 15 divided by 3, that means there needs to be 5 in each group. So let's just do circles. They're easiest. 1, 2, 3, 4, 5. There's one group of 5. 1, 2, 3, 4, 5. There's my second group of 5. 1, 2, 3, 4, 5. My third group of 5. Now let's review and figure out, how did I know that I'm breaking 15 into 3 groups of 5? Remember, the denominator here will tell you how many groups you need. All right, so when the denominator is smaller than that whole number, it tells you how many groups you need. You need 3 groups. And use your fact family. 3 times 5 gives us 15, or 15 divided by 3 gives us 5. So that means we need 5 in each of these 3 groups to give us the total of 15. And we're looking at 2 of the 3 groups. So put a ring around these 2 of the 3 groups and count how many we have. We have 10 models. So 2/3 times 15 equals 10. All right, let's confirm it. Let's just go up here and let's do 2/3 times 15 over 1. All right, hopefully you all know that 15 times 2 is 30, and 3 times 1 is 3. And hopefully you all know your tens table, so that will help you, your 10 times tables, to divide this improper fraction. 30 divided by 3, we can do it in our head. That's a basic fact, and we get 10. So that confirms that 2/3 of 15 should be 10, and we do see that here. All right, let's do another one. Now this one's a little different because the denominator is greater than the whole number. So that tells me this one right here is going to be more like number 4. All right, and the way that I knew how to draw this is I know that I have 6 of something. So let's just use 6 circles. And I need to break these circles into 12 equal parts. So you know what? Using my fact family, I know that if I break each circle into 2 equal parts, 6 times 2 gives me that 12. So let's look at this. Now I know these aren't perfect. If they were all drawn perfectly, I would have 12 equal parts, right? My model is broken into 12 equal parts. And I'm looking at 11 of them. So I'm going to put a ring around all of them except the last half here. And I have 1, 2, 3, 4, 5 full circles and a half. So I get the product 5 and a half. All right, again, if you need to rewind it and see the difference between 5 and 6, okay, you can do that. Now let's check it with the standard algorithm. So let's take 11/12 times 6 over 1. All right, we should know our 11 tables. That's easy. 6 times 11 is 66, and 12 times 1 is 12. All right, now you do need to know your 12 tables to be able to do this in your head. If not, you need to go out to the side and divide 12 into 66. I know 12 times 5 is 60, so that's where I'm going to start. I have 6 left over, so that becomes the numerator, and the denominator is the divisor, which started out as the denominator to start with, so I have 5 and 6/12. I know that's not 5 and a half, but that kind of gives me a hint that I need to look at the numerator and denominator, and the numerator is half the value of the denominator. So yes, I have 5 and a half. So my model is correct. All right, number 7, is that going to be more like number 5, or is it going to be more like number 6 when we work it out? 5/8 times 16. It is going to be more like number 5 because my whole number is more than my denominator part. So that means I'm going to take 16 of something and I'm going to make 8 equal groups. So the question is, how many are going to be in each group? So I'm going to make 8 groups of something to equal 16. I just use that math fact. 8 times what is 16, or 16 divided by 8 is 2. Oh, I just said it. So here I go. I'm going to have groups of 2. There's 1 group, 2 groups, 3 groups, 4, 5, 6, 7, 8 groups of 2. All right, that gives me 16 circle models here, right? And I want to focus my attention on 5 of these groups. So 1, 2, 3, 4, 5. I'm going to put a ring around these 5 groups. And I'm going to look at how many circles are in here. So in these 5 out of 8 groups, I have 2, 4, 6, 8, 10. So I get a product of 10. And again, like I said, if I'm not really comfortable with models, I like to go ahead and use what I do know, which is using an equation and doing 5/8 times 16 over 1. All right, I'm going to do a quick little work here. 16 times 5. 5 times 6 is 30. 5 times 1 is 5 plus 3. I get 80 over 8 times 1 is 8. And I can do that in my head. 80 divided by 8 is going to be 10. Now my 10 tables. 10 times 8 is 80. And that confirms my answer. So boys and girls, you have basically a good way to check to see if you have your models right, at least the answer part right, okay? And you have some good examples. So when you are working on your practice buddy, please make sure you have filled out your book. If you haven't done it yet, pause it right now. Just pause it and go back in and work on this. Okay, we worked out all the problems here. Scratch works on the side. Okay, make sure you have all your answers, so pause it where you need it. But by the end of this lesson, you should have been able to use these models to multiply a whole number by a fraction. So good luck with your practice buddy. If you don't like your score, if it's something going on with the models and you understand it by the end of the practice buddy, take a quick couple of 5 minutes and go back and redo it so that you do a better job. I highly suggest you get a sheet of notebook paper. If you would, just like we did in class yesterday, head your paper lesson 8-2, L8-2, head it multiply a whole number by a fraction, and work out your practice buddy problems on the paper. You can always staple your paper in your book, or you can put it in your binder behind math work. Have a great day, and I will see you soon.